You know, usually when we talk about human progress, we have these incredibly vibrant, culturally rich milestones in our heads.
Oh, absolutely.
Like, you think about the Renaissance, right? The explosion of art, the radical shift in science and philosophy. Or you think about the Apollo moon landings.
Yeah, or even just the birth of the internet.
Exactly. We have this expectation that advancement is this very human, very visible tapestry of achievements.
Right, because we measure our advancement by our artifacts, by the things we create, the poetry we write, the treaties we sign, the digital networks we build.
Yeah.
It's an entirely anthropological view of success. We categorize the universe by our own cultural standards, assuming that, the pinnacle of civilization looks something like a highly educated, diplomatically peaceful human society.
But then you step into the world of theoretical astrophysics and long-term planetary survival.
Right.
And suddenly that whole anthropological tapestry just gets rolled up and tossed out the window.
Totally out the window.
Oh, we are looking at a metric for civilization today that is, honestly, it's quite brutal in its simplicity.
It really is. I mean, it strips away the ego of a species entirely. It ignores all the things we are most proud of.
Yeah, the art, the politics.
Exactly. It ignores our political systems, our philosophies, and it looks strictly at the cold, hard, universal mechanics of existence. The universe doesn't care about a beautiful symphony.
No, it does not.
It cares about thermodynamics.
It really does. So, welcome to the deep dive. Today we are taking a fascinating journey, and we want you right here with us as we explore a really profound new piece of writing.
That's a great piece.
Yeah, we're looking at a brand new Substack article that just dropped today, April 29, 2026. It's from a publication called SpiralSeekr.
Right.
And the article is titled Beyond Survival, Rethinking the Kardashev Scale. And our mission today is pretty ambitious.
Very ambitious.
We are going to explore exactly how we measure the progress of a civilization when we zoom out to a cosmic level. We're going to strip away the culture, strip away the politics, and look at the awe-inspiring mathematics of energy consumption.
And examine what that means for humanity's ultimate survival.
Right.
Because this is a vital reframing of how we view ourselves. This isn't just, an exercise in science fiction or distant speculation.
No, not at all.
The concepts SpiralSeekr lays out force us to take a profound look at our own precarious existence right now, today, on this planet.
Yeah.
But through a lens completely devoid of human sentimentality.
Okay, let's unpack this. Think about human progress in your day-to-day life, right? You probably think about the device you're listening to us on, or, I don't know, medical breakthroughs we've achieved.
Or the social structures we've built over centuries.
Right, exactly. But what if the only metric that truly matters for our long-term survival, like the only thing the universe actually respects, is how we plug in our devices and power our cities?
Yeah.
What if progress is just a raw measurement of power?
To grasp that, we really have to look at the origin of the concept itself. The article introduces us to the astrophysicist Nikolai Kardashev.
Right, back in the 60s?
Yeah, 1964. Kardashev was looking for signs of extraterrestrial life. He was specifically analyzing quasars, which are these incredibly bright, energetic galactic cores.
Just massive energy output.
Huge. And he realized that if we were going to look for alien civilizations, we needed a way to categorize them based on something we could actually detect across the vastness of space.
Because, you can't detect an alien philosophy through a radio telescope.
Exactly. You can't detect a poem.
Yeah.
But you can detect a massive manipulation of energy.
And that gave birth to the Kardashev scale.
Right.
The fundamental premise of this scale, as SpiralSeekr lays out perfectly, is that it measures a civilization's technological advancement based solely on the amount of energy it can use.
Solely on energy.
Just energy. No extra points for having a really great democracy.
No deductions for bad art.
Yeah, exactly. Just pure energy.
What's fascinating here is how beautifully simple but ruthless this metric is. Energy is the universal currency.
Yeah, everywhere.
Right. Whether you are on Earth or on a planet orbiting a star a billion light years away in the Andromeda galaxy, the laws of thermodynamics apply identically.
They don't change?
They don't. If a civilization wants to sustain itself, if it wants to grow, to build, to defend itself against the harsh realities of the universe, it needs work to be done.
Right.
And in physics, work requires energy. Therefore, in the grand cosmic ledger, energy consumption equals survival. It is the only objective baseline we can use to compare ourselves to the unknown.
I hear that, and I understand the mathematical elegance of it, but I have to push back a little bit here.
Oh, sure.
Let's look at the context of when this was created. Kardashev was a Soviet astronomer writing in the 1960s. That was the absolute peak of the Cold War and Soviet industrialism.
Right, the space race, all of that.
Yeah. Isn't the scale inherently biased? I mean, it assumes that bigger and more power-hungry always means better.
Yep.
Could you have a society that is highly advanced mathematically, scientifically, spiritually, but they just choose to live a minimalist existence?
You mean like a utopia kind of thing?
Yeah. Like they synthesize their food efficiently, they stabilize their population, they use very little energy, but they're incredibly enlightened. Doesn't this scale completely invalidate a highly advanced but low-energy society?
That's a great point. The criticism of Kardashev's Soviet industrial bias is common, but it misunderstands the physical reality of a static system over long time frames.
Okay. How so?
SpiralSeekr actually addresses this underlying logic.
Yeah.
The text dictates that the more advanced a society becomes, the more energy it needs to sustain itself and grow.
Right.
Growth isn't just an economic desire in this context, it's a thermodynamic necessity for long-term survival.
We see.
An enlightened low-energy society might be perfectly happy for, say, 10,000 years. But eventually, their star will fluctuate, or a rogue planet will disrupt their orbit.
Or a nearby supernova bathes their system in gamma radiation.
Exactly. Deadly radiation.
So it's an issue of active defense versus passive existence.
Precisely. Because if an asteroid is on a collision course with their planet, their philosophical enlightenment will not deflect it.
No matter how peaceful they are.
Right. A deep understanding of ethics cannot alter orbital mechanics. Only kinetic energy, raw power, can do that.
Wow, yeah.
A low-energy civilization is, by definition, at the mercy of the universe's random, chaotic events. To survive on a cosmic timescale, we're talking millions or billions of years, you must possess the energy capacity to actively manipulate your cosmic environment.
Ah, okay. So it's not about industrial bragging rights. It's about agency.
Exactly.
Think of it like this. For everyone listening, imagine you are evaluating a ship heading into a massive, unpredictable ocean.
Okay.
A low-energy, highly philosophical society is like a beautifully crafted, perfectly balanced sailboat. The crew is happy, they work in total harmony, the sails are pristine.
Sounds lovely.
Right. But they're entirely at the mercy of the weather. If Category 5 hurricane forms, that sailboat is going down regardless of how enlightened the crew is.
Absolutely going down.
But a civilization high on the Kardashev scale is like a nuclear-powered icebreaker. It might be loud, it might be industrial, but when the storm hits, it has the raw engine horsepower to smash through the ice and power out of the danger zone.
That's a perfect analogy.
So it doesn't matter how comfortable the ride is if the engine can't get you out of the path of a storm. The Kardashev scale isn't measuring the quality of the society, it's measuring the horsepower of the survival engine.
And the universe is full of metaphorical hurricanes. Asteroid impacts, ice ages, stellar flares, orbital decay.
Yeah.
The Kardashev scale measures your engine's ability to move you out of the way of those threats.
That is a terrifying but incredibly clarifying way to look at it. We are judging our cosmic horsepower.
We are.
So now that we understand the ruler that is being used to measure civilizations, let's look at the very first notch on that ruler. Let's talk about where humanity currently sits and the math behind our immediate future.
Right.
The article breaks this down into types, starting with type I.
So a type I civilization, according to the text, is one that can harness and use all the available energy reaching its home planet from its parent star.
As well as the energy produced by the planet itself.
We are talking about capturing the full potential of planetary energy resources.
SpiralSeekr specifically lists the required sources here: solar, wind, and geothermal energy. But here is the massive aha moment that I think a lot of people miss when they hear about the Kardashev scale.
Oh, the scoring.
Yeah. The scale is logarithmic. It's not a simple 1 to 100 rating. The article states that humanity is currently sitting at a 0.73 on the Kardashev scale.
Which sounds high.
It does. When you hear 0.73 out of 1.0, it sounds like we are 73% of the way there. Like we just need to build a few more solar panels and we'll cross the finish line.
But the mathematics of a logarithmic scale paints a much more daunting picture.
Yeah, explain that math for us.
Well, the formula we use today, which was actually refined by Carl Sagan based on Kardashev's work, it calculates a civilization's rating based on its total power output in watts.
Okay.
Our 0.73 rating means we are currently utilizing roughly 10 to the 13th power watts of energy globally.
10 to the 13th.
Right. But full type I civilization utilizes 10 to the 16th power watts.
Oh, wow. So we aren't 73% of the way there. We are 3 whole orders of magnitude away.
We are.
We have to increase our global energy output by roughly 1,000 times to reach Type I status. That is a staggering gap.
It's an immense evolutionary leap. And to understand why we are stuck at 0.73, the author points to our current dependency. The text notes that we are still heavily reliant on what SpiralSeekr calls dead plants.
Oh man, I love that phrasing. Dead plants.
It's very accurate.
It is a humorous but deeply grim way to describe our reality. I mean, you look around at our society today, we have artificial intelligence writing code.
Right.
We have quantum computers modeling molecular structures. We have rovers autonomously driving around the surface of Mars, beaming high-definition video back through
It
space.
feels very advanced.
It does. But at the foundational level, like the bedrock of our civilization's energy grid, we are fundamentally just digging up ancient compressed vegetation, setting it on fire, and using the heat to boil water to spin turbines.
It's basically a steam engine.
Yeah. Despite all our silicon and algorithms, we are a combustion-dependent species.
It really humbles our technological pride, doesn't it?
Totally.
We view ourselves as the apex of modernity, but our primary mechanism for survival is fundamentally primitive. We are burning our planet's finite geological savings account to keep the lights on.
Yeah.
And that ties directly into the crucial caveat of reaching Type I, that the article emphasizes perfect balance.
Right. The text states this energy extraction must be perfectly balanced so that the planet's ecosystem remains stable.
Because you cannot reach Type I by simply burning 1,000 times more dead plants.
Right. Obviously not.
The thermodynamic waste, the heat, and the atmospheric carbon would literally boil the biosphere long before you reach 10 to the 16th watts.
Yeah, we'd cook ourselves.
Exactly. Therefore, reaching Type I requires integrating your energy needs seamlessly into the planet's natural cycles.
Let's explain how that perfect balance actually works, because it's not just about, planting trees or recycling plastic. It's about thermodynamics.
Yes.
So for you listening, I want you to imagine the Earth not as a rock, but as a closed-loop biological circulatory system, kind of like the human body.
That's a great way to picture it.
Thanks. When your body consumes energy, it produces waste and heat. But your circulatory system, your lungs, your skin, they constantly manage that heat and expel the waste, so your core temperature remains a stable 98.6 degrees.
Right.
If you suddenly tried to sprint 100 times faster, your body couldn't shed the heat fast enough and you would die of hyperthermia.
That is a highly accurate thermodynamic analogy, because a planet has a thermal budget. It receives a specific amount of energy from the sun, and it radiates a specific amount of heat back into space.
Okay.
Right now, by burning fossil fuels, we are adding trapped heat to the system faster than the planet can radiate it away.
A hyperthermia.
Exactly. To become a Type I civilization, we have to build a global energy grid that acts like a perfectly evolved circulatory system. We must harness solar, wind, and geothermal power at massive scales.
Meaning capturing the energy that is already in the system.
Yes, exactly. And utilizing it without altering the planet's baseline thermal budget.
It's an intelligence test for the entire species.
It is the ultimate bottleneck. The challenge isn't finding more things to burn. I mean, the universe is full of combustible material.
Sure.
The challenge is managing exponential resource consumption without causing your own extinction through thermodynamic waste.
Right.
You need the global political coordination to build a unified grid, the material science to capture energy with near-perfect efficiency, and the atmospheric engineering to manage the waste heat.
And if we fail?
Failing that intelligence test means your species simply becomes a brief, self-limiting biological anomaly in the geologic record. You don't survive to see Type I.
Wow. So I guess, we are like a teenager who has found the keys to the family car, the fossil fuels, and is driving incredibly fast, but hasn't yet learned how to actually maintain the vehicle?
Or stay on the road?
Yeah. We haven't figured out the balanced ecosystem. We are dangerously close to crashing before we even get our full license, which would be Type I.
Transitions are the most dangerous periods for any complex system. You have the destructive power of the new paradigm, but you still have the maturity and infrastructure of the old paradigm.
Yeah.
We are trying to thread a very narrow needle between technological stagnation, and ecological collapse.
But let's assume we thread that needle. Let's be optimistic for a second. Let's assume humanity figures out the global grid. We transition away from dead plants. We master our atmospheric chemistry. And we achieve that perfectly balanced 10 to the 16th watts circulatory system.
Okay, we become a Type I civilization.
We become a Type I civilization. The paradox of the Kardashev scale is that you can't just stop there, right?
Yeah,
The laws of thermodynamics and the imperative of survival kind of force your hand.
they absolutely do.
Mm.
Once you master your home planet, you inevitably hit a hard physical ceiling.
Yeah.
Because even with perfect efficiency, a planet only receives a tiny fractional sliver of the energy produced by its parent star.
Right. Most of the sun's energy just blasts out into empty space.
Exactly. And a society that has mastered its planet will continue to grow in population, in computational needs, and in scientific ambition. To feed that growth, you must look outward. You must go to the source.
Which brings us to the next leap. Reaching Type I is our first major hurdle, but what does the next evolutionary leap look like?
This brings us to a Type II civilization.
According to the source, a Type II civilization is a society that has outgrown its planet entirely and can harness the entire energy output of its host star, our sun.
Right.
And the scale of what we're talking about here is just, it's difficult to hold in your head, but the article points to the hallmark engineering concept of a Type II civilization.
The Dyson sphere.
Yes, the Dyson sphere. Here's where it gets really interesting.
The text defines the Dyson sphere as a massive structure built around a star to capture its power. First proposed by physicist Freeman Dyson in 1960, it represents the ultimate leap in macro engineering.
Now, I know a lot of people listening are probably familiar with the term Dyson sphere from science fiction, but let's break down the actual mechanics of what SpiralSeekr is talking about here because, it's rarely depicted accurately in movies.
Very rarely.
When people hear massive structure built around a star, they picture a solid, rigid shell, like a giant metal ping pong ball with the sun trapped inside.
Hey.
But the physics of a solid shell are impossible, right? Like the structural integrity wouldn't hold against the star's gravity, and any slight orbital perturbation would cause the shell to just crash right into the sun.
A solid shell is a very common misconception. When astrophysicists discuss a Dyson sphere, they're typically referring to what is more accurately called a Dyson swarm.
A swarm.
Instead of a solid shell, imagine millions or billions of independent solar collectors, habitats, and power relays orbiting the star in a dense, intricately choreographed formation.
Oh, wow.
This swarm essentially encompasses the star, capturing a significant percentage, if not all, of its radiative energy output.
And the leap in imagination, let alone material science, required to build a swarm of that magnitude is just staggering. You can't just mine iron from the Earth to build it.
Oh no, Earth doesn't have nearly enough mass.
You would literally have to disassemble other planets. You would have to mine Mercury down to its core, launch the raw materials into orbit using mass drivers, and use automated factories to construct billions of square kilometers of solar collectors.
You cease being a passenger in the solar system.
Yes.
You become the architect of it. You look at the sun not as a sky object, but as a literal appliance to be enclosed and harvested.
The transition from Type I to Type II is the transition from planetary management to stellar harvesting. And the mechanism of how this energy is used is equally fascinating. Right, because you have billions of collectors orbiting the sun. How do you get that power to where you need it?
You beam it. The swarm would likely use microwave or highly focused laser arrays to transmit colossal amounts of energy safely to receiver stations on the home planet.
Or to orbital habitats, or to deep space propulsion systems.
Exactly.
And the article outlines the transformative benefits of having a star as a dedicated battery. It states that at this stage, a civilization becomes immune to most natural disasters. They can run massive planetary scale operations and conduct deep space exploration.
The sun becomes their battery.
But I want to ask a clarifying question here because I want to zero in on this idea of immunity. It fundamentally shifts the relationship between a species and the universe. How does capturing a star's energy make you immune to a natural disaster on a planet?
It comes down to raw kinetic and thermal authority. We discussed earlier that a Type I civilization has mastered its own planet's internal systems.
Right.
But a Type I is still vulnerable to external cosmic forces. A Type II civilization possesses the energy capacity to actively override nature.
Override it?
Yes. The text notes that at this stage, civilizations can run massive planetary scale operations. With the sun as an unlimited battery, a civilization possesses the raw power to engineer climates or deflect asteroids.
So if a massive asteroid like a planet killer is detected entering the solar system, a Type 2 civilization doesn't scramble to launch a tiny kinetic impactor like we do.
No, they don't need to. They just focus a fraction of their Dyson Swarm's output, create a phased laser beam powered by the sun itself, and vaporize the asteroid from millions of miles away.
That is wild. Or what if the threat is the planet itself? What if a supervolcano is destabilizing or tectonic plates are shifting in a way that threatens global infrastructure?
Well, with 10 to the 26 watts of power at your disposal, which is the approximate output of our sun, you can engage in active planetary engineering. You can drill down to the mantle and use directed energy to bleed off pressure from a supervolcano.
You're kidding.
No, the physics allow for it. You can artificially manipulate the planet's magnetic field to deflect severe solar storms. You can even perform stellar lifting.
Wait, what is stellar lifting?
It means you use magnetic fields to siphon plasma off the surface of the sun itself, extending the star's lifespan and preventing it from expanding into a red giant and swallowing your planet.
Oh my goodness. So a Type I civilization is merely surviving nature. They're in balance, but they are still playing by nature's rules.
Right.
But a Type 2 civilization dictates the rules. They have absolute control over their local neighborhood. The sun is their battery. The solar system is their sandbox.
That's a great way to put it. At Type 2, you aren't just weathering the universe's storms. You control your environment so absolutely that natural disasters are no longer a threat.
But again, the Kardashev scale doesn't stop. Using a star as a battery gives a civilization absolute control locally. But what happens when a species looks beyond its own star system, realizes that one sun isn't enough, and decides to wire up the entire galaxy?
This is where we cross the horizon into the truly incomprehensible. The article defines a Type 3 civilization as one operating on a completely different level, capable of harnessing the energy of an entire galaxy.
An entire galaxy. We are talking about hundreds of billions of stars. It's a scale that just breaks the human brain. The jump from Type 2 to Type 3 is a massive, massive leap.
It really is.
And SpiralSeekr lists the unimaginably complex physics that would be required to achieve this, specifically mentioning faster-than-light travel, advanced robotics, and the ability to tap into black holes or dark energy.
Each of those three technological pillars represents a profound departure from our current understanding of physics, and each is strictly necessary for a Type 3 civilization to function as a cohesive entity.
Let's break down those three pillars, starting with faster-than-light travel, or FTL. Under our current understanding of relativity, nothing can travel faster than the speed of light in a vacuum. And the Milky Way galaxy is roughly 100,000 light-years across. So if you are limited by the speed of light, it takes 100,000 years just to send a basic radio transmission from one side of your civilization to the other.
You can't have a unified culture, an economy, or an energy grid if causality itself is delayed by millennia.
Exactly. Without FTL, you don't have a single Type 3 civilization. You just have millions of isolated, lonely Type 2 outposts that eventually diverge into entirely different species.
Therefore, a Type 3 civilization must have solved the physics of FTL. Whether that involves manipulating the Alcubierre metric to warp spacetime around a vessel, or utilizing stable wormholes to create shortcuts through higher dimensions, they have mastered the manipulation of spacetime itself.
Wow. And the second pillar the article mentions is advanced robotics. Now, when the article says advanced robotics in this context, it implies something much deeper than autonomous assembly lines, right?
Much deeper. To conquer and re-engineer billions of star systems, biological beings, creatures of flesh, blood, and water like us, are entirely inadequate.
Yeah, space is terribly hostile to biology.
The timescales, the cosmic radiation, the sheer physical labor, and the absolute lack of life-sustaining environments across the galaxy demand a non-biological approach.
So what are we talking about here?
The mechanism here relies on von Neumann probes.
Oh, self-replicating spacecraft.
Exactly. A Type 2 civilization would launch these robotic probes to neighboring star systems. Once there, the probe mines local asteroids, builds a replica of itself, constructs a Dyson Swarm around the new star.
And then the original probe and its replica launched to two new systems.
Yes, it is an exponential robotic infection of the galaxy. Biology is fragile and tied to a narrow set of planetary conditions. To wire up a galaxy, you need an intelligence that isn't burdened by the need for oxygen or a narrow temperature range.
The vanguard of a Type 3 civilization is entirely machine.
Exactly.
Which brings us to the third and perhaps most terrifying power source mentioned in the article. Once you have swarmed the stars, where do you find more energy? SpiralSeekr mentions tapping into black holes or dark energy.
This is where a civilization transitions from manipulating matter to manipulating the fundamental fabric of the universe.
Yeah.
Harvesting energy from a black hole isn't science fiction, it is mathematically sound physics, primarily through a mechanism called the Penrose process.
Okay, let's explain how that actually works, because it sounds like magic. How do you get energy out of something whose entire definition is that nothing can escape it?
It's fascinating.
Mm-hmm.
It relies on rotating black holes. A spinning black hole literally drags the fabric of space-time around with it.
Frame dragon.
Right.
GI.
Yes, frame dragging. It creates a region outside the event horizon called the ergosphere. If a highly advanced civilization drops mass into the ergosphere, and that mass splits in two, with one half falling into the black hole and the other half escaping?
The escaping half actually steals rotational energy from the black hole itself.
Exactly. It comes out with more energy than it went in with. You are essentially using the black hole as an infinitely dense spinning flywheel to generate unimaginable amounts of power.
That is just wow. And the article also mentions dark energy. We know the universe is expanding, and that expansion is accelerating. Dark energy is the placeholder name for the mysterious force driving that acceleration.
Right, and it makes up roughly 68% of the universe.
So if a civilization can tap into the vacuum energy of space itself, the cosmological constant, they have access to a truly infinite power source. They are harvesting the expansion of reality.
And this is why the article provides that ultimate chilling description. If we connect this to the bigger picture, it states that to us, a Type 3 civilization would look less like a species and more like a force of nature.
Yeah.
Their engineering projects harnessing black hole ergospheres, manipulating galactic dark energy, warping spacetime would be so vast and so deeply integrated into the fundamental physics of the universe that they would look like natural cosmic phenomena to less advanced observers.
I want you all listening to try and visualize this with an analogy. Imagine you are an ant. You live in your anthill, you understand dirt, you understand leaves, you understand the pheromone trails of your colony. Now imagine a crew of human engineers comes along and builds a massive 10-lane concrete highway right over your anthill.
Right.
As an ant, you do not perceive that highway as technology. You don't look at the asphalt and think, an advanced bipedal civilization built this for mass transit. Your brain lacks the framework for transportation infrastructure.
The scale is so massive that to the ant, the highway is just a new, terrifying feature of the natural landscape.
Exactly. It's a smooth, black, impenetrable rock that goes on forever.
The ant cannot comprehend the intent, the mechanics, or the existence of the engineers. The ant only perceives the physics of the obstacle.
That is exactly how we would view a Type 3 civilization. We wouldn't recognize it as engineering.
We couldn't.
And this staggering scale, this idea of becoming indistinguishable from the universe itself, it forces us to look inward. This brings us to the final section of the article, which pivots from physics to philosophy.
It's a very necessary pivot.
Yeah, the author brings us back to humanity's current state. We are sitting at point 73, navigating this delicate transition, trying to balance our planetary thermodynamics before we cook ourselves. But then the article poses a profound concluding question.
Right.
If we eventually reach a point where we can control stars, extract energy from black holes, and span a galaxy, will our goals and desires still be recognizable? Or will the sheer scale of our power completely change what it means to be human?
This raises an important question, and it gets to the heart of the paradox of the Kardashev scale. It's a brilliant synthesis by the author.
Yeah.
The paradox is the very pursuit of survival, the drive to master supreme energy to ensure our existence against the chaotic indifference of the universe might ultimately erase the very human traits we are trying to preserve.
I want you to think about your own daily desires. Think about what drives you right now. You want love, you want to create art, you seek physical comfort, you have ambition for your career, you want to protect your family. Every single one of those human desires is forged by our biological limitations.
Absolutely.
They are forged by the fact that we are fragile, that our time on this planet is strictly limited, that resources are scarce, and that we require constant chemical energy food to survive.
Our psychology is an artifact of our evolutionary environment. We were optimized for survival on the plains of a specific rocky planet orbiting a specific yellow dwarf star.
But if you completely remove that environment, the psychology must irrevocably change. A civilization that operates at type 3 is almost certainly post-biological.
They have likely digitized their consciousness or merged entirely with their synthetic architecture.
Exactly. If you exist as a distributed intelligence across a galactic network, processing information via the Hawking radiation of a black hole, you do not experience hunger, you do not feel the winter cold, you do not have a 100-year lifespan that pressures you to leave a legacy.
No.
If you remove scarcity and mortality, do human desires still exist? Or do you desire completely different, incomprehensible things?
Information theory suggests that at a certain level of complexity, the imperative shifts from biological survival to the sheer processing and storage of information.
Wow.
A Type 3 entity doesn't write poetry about human sorrow. It dedicates its computational mass to modeling the multiverse or altering the cosmological constants of its local space.
It's just a different reality.
The biological imperatives of the past would seem as irrelevant to them as the concerns of a single cell in your bloodstream are to your conscious mind.
So what does this all mean? Mastering energy is a profound double-edged sword. On one hand, the cold mathematics of the universe dictates that climbing the Kardashev scale is the only way to guarantee our survival against the random cruelty of the cosmos.
Right.
If we stay at 0.73, or even type I's, we eventually succumb to a cosmic event. But on the other hand, climbing that scale guarantees that the thing that survives at the end of that billion-year journey will absolutely not be what we currently consider human.
That is the ultimate cost of cosmic survival. You must shed your original form to endure the long game of the universe. The intelligence survives, the data survives, the thermodynamic agency survives.
The humanity.
The fragile, combustion-dependent, poetically flawed humanity is outgrown, discarded like a caterpillar's cocoon.
What a profound, heavy journey this article takes us on. Let's do a quick recap to pull all these massive concepts together for you. We started by looking at the harsh reality of the Kardashev Scale, which strips away human ego and measures progress solely through thermodynamic capability.
Right.
We examined our current reality humanity sitting at a fragile 0.73, desperately burning ancient dead plants, and trying to build a perfectly balanced, closed-loop planetary energy grid before we destroy our biosphere.
And from there, we looked at the Type 2 leap, the astonishing macro-engineering required to dismantle planets and build a Dyson Swarm, capturing the entire 10 to the 26th watts output of our sun.
Yeah.
This transitions a civilization from mere planetary survival to absolute environmental immunity and active stellar defense.
And finally, we stared into the abyss of a Type 3 civilization, a post-biological society capable of spanning a galaxy, utilizing faster-than-light travel, extracting rotational energy from black holes, and operating on a scale so vast that surviving to that point means sacrificing our humanity entirely.
Right.
It's a lot to process.
It is an overwhelming perspective shift.
Yeah.
But I want to leave you with one final haunting thought.
Yeah.
It builds directly on SpiralSeekr's concept of a Type 3 civilization, looking less like a species and more like a force of nature.
Okay.
Consider this. The article states that a Type 3 civilization tapping into black holes and dark energy will look less like a species and more like a force of nature. We currently look up at the night sky with our telescopes. We observe the accelerating expansion of the universe, driven by this mysterious, ubiquitous force we call dark energy.
Yeah.
We see the massive, inexplicable gravitational pull of supermassive black holes anchoring the center of almost every galaxy. And we categorize all of this as natural, unthinking physics. But if a sufficiently advanced civilization is truly indistinguishable from the fundamental mechanics of the cosmos,
Wait, how do we know we aren't already staring directly at a Type 3 civilization's infrastructure right now, simply lacking the sensory capacity to recognize it as someone else's technology?
are we just the ants looking at the highway? Man. It's a question that completely rewrites how you look at the stars. We want to thank you so much for joining us on this deep dive. I highly recommend taking a moment tonight to step outside, look up at the night sky, and wonder about the unimaginable energy flowing through it all and who might be directing it. Until next time.